In order to graph cosecant, you have to think about the sine function because they're reciprocals. So your sine function, if you look at our unit circle, isn't sine 0 at 0 and 2 pi? Okay. And sine is also 0 at pi. Okay. So that means if I do the reciprocal, let me turn these into fractions. Sine of 0, that's 0 over 1. So if I do the reciprocal, that means cosecant is 1 over 0 at this location, and cosecant is 1 over 0 at this location. That is not possible. You cannot have 0 in the denominator. So that means cosecant is undefined at pi and at 0 and 2 pi. Does that make sense? Okay, so you might need to write that down. Cosecant is undefined at 0, pi, 2 pi, and so on. So let's go ahead and graph the sine function. The sine function, you're going to graph it in 2 pi. And we have to split it into 4 equal parts. So this will be pi over 2, pi, and 3 pi over 2. And when you graph the sine function, you always start here. You go up, back to the midline, down, back to the midline. So this is your sine function. We're going to do a dashed line for sine. Now, remember what we said about cosecant. It's undefined at these locations. So since it's undefined there, I'm going to draw asymptotes at 0, because there's an asymptote there, because cosecant is undefined there. I'm going to draw an asymptote at pi and at 2 pi, because cosecant is undefined at those locations. Now let's talk about graphing. All right, so at pi over 2, let's look at my unit circle. Sine is 1. What is cosecant? Okay, I'll turn this into a fraction. Can you flip that fraction? It's just 1. So cosecant is also 1. So at pi over 2, I'm going to put the point 1. Let's look at 3 pi over 2. Sine is negative 1. I'm going to turn it into a fraction. If you flip the fraction, it'll be 1 over negative 1. So what is cosecant? Negative 1. So at 3 pi over 2, put a point at negative 1. Okay, we can continue going around the unit circle. I'm just going to do one just so you can see it. Do you need to plot it? No, I'm just going to show you. Here, this is the angle pi over 4. What is the value of sine at pi over 4? Yes, square root of 2 over 2. So if you flip it, cosecant at pi over 4, you have to flip it. What will you end up getting? So just square root of 2? Good. All right, that's about 1 point something. I'll just graph it right here, a little above 1. So basically, guys, your graph is going to look like this, going towards the asymptote. You can plot more points if you want to. But it'll look like that. So let me put some notes on here. When you're graphing cosecant, your asymptotes are always on the midline. So notice you had a point here for sine, a point here for sine, and a point here for sine. Your asymptotes always go through those points that are located on the midline. You guys see that? Okay, your asymptotes are always on points located on the midline. Okay? Your graph for cosecant, it's always going to be, this was a maximum for sine, and this was a minimum for sine. So cosecant is always drawn on the maximum and minimums. Okay? So I'll write that down. When you graph it, it's always on maximums and minimums. And guys, just like the sine function goes on forever, just like this goes on forever, so will your cosecant graph. So you could continue this pattern. It'll just look like this. You can continue it on this side too. It'll look like this. Okay, let's answer the rest of the questions. We want to know what the domain is. So your domain is, your first asymptote is right here at 0. So x cannot be, it can't be here. And what's the distance between here and the next asymptote? Yep, pi. So you cannot be any interval of pi. So I'm going to put an n there. N is an integer. Please write that down. Your vertical asymptote will be the exact same equation, except for it'll have an equal sign. So let's test this. I'm just going to plug in a number for an integer. Okay, so if you plug in a 4, pi times 4 is 4 pi. And if you continue this pattern, you will have this is 3 pi. This is 4 pi. So you'll run into an asymptote. If you want to test another number like 2, that's 2 pi. And look, you have an asymptote at 2 pi. You want to test a negative number like -2, you'll have an asymptote at -2 pi or -3. All right, so you can always test your equation, make sure it checks out. Let's talk about the range. Your range is from the bottom to the top. So down here, it's pointing to -infinity. And it goes up to right here, which is at -1. Then it continues right here at +1 and goes up to infinity. There is no vertical or horizontal transformations because we're just talking about the parent function right now. We're not doing any type of transformations. All right. So what do you guys think the relative maximum is? Okay, thumbs up if you agree. What's the maximum? Relative max. Relative max.
1.
Okay, that's pretty much what everyone says. Everyone always picks this point. That's actually the minimum. You see how it's at the bottom? So this is the relative minimum. So that's at pi/2, 1. And this is the relative maximum at 3 pi/2, -1. This is called the relative maximum because it's the maximum point for this little area. This one right here is called the relative minimum because it's the lowest point in this little section. Okay. All right, so that's how you graph cosecant. Okay, next. In order to graph secant, you guys should be thinking about cosine. So if I graph cosine, I always graph it within 2 pi. So I'm going to put 2 pi here and split it into equal parts. Now notice cosecant is 0 at 3 pi/2 and it's 0 at pi/2, right? So that means secant is undefined at these two locations because if you flip those fractions, you'll get 1 over 0, right? Okay, so that means I'm going to have asymptotes at those two locations. Before I draw my asymptotes, let me go ahead and draw cosine. Cosine looks like this. That's cosine. Now, if I want to draw secant, you have asymptotes at 3 pi over 2 and pi over 2. So here's my asymptote at pi over 2 and 3 pi over 2. I have asymptotes there because secant is undefined in those spots. In the same way, I'm just going to go ahead and graph it. So this will look like this. This will be facing down. This will look like this. And guys, this pattern will continue. You do not have to draw this. I just want you to know what it looks like. This will continue like this. However, I'm not including the rest of this because we're only graphing one period. We're not going on forever. We're just graphing one period from here to here. So I don't need to include all of these extra ones. I just want you to understand that it's a cycle, so it keeps going. So you don't have to draw the other sides. All right, so that is my secant graph. Now we can answer some questions. Your domain, x cannot be where the asymptote is. So your first asymptote is at pi over 2. And where is the next asymptote? How far is the next asymptote? Just pi, right? It's only pi away. From here to here is pi over 2. From here to here is pi over 2. That's pi. Also, if you think about the unit circle, here's pi over 2, and here's 3 pi over 2. That's a distance of pi away. Because I want to represent, I need this in right here because I need to get every asymptote, not just the first one. So for example, if I plug, let's use that equation, pi over 2 plus pi, my in value, if I plug in, let's say I plug in a 1, this will be pi over 2 plus pi, get the same denominator, so put this as a 2 and a 2. That's 3 pi over 2. That's where your next asymptote is. If you plug in a 2, this will become 2 pi. Get the same asymptote, that'll be a 4. This will be 5 pi over 2. Then this is your next asymptote. You can plug in negative asymptotes, so you can plug in a -1. If you plug in a -1, you'll be right here at negative pi over 2.
So why are we using pi over 2, not like negative?
I don't have to write negative pi over 2 because if I plug in stands for any integer. So you can plug in negative numbers and get the negative side.
Oh.
Okay, does that make sense? Okay. So this equation that I wrote accounts for both sides, going left and right. Okay, let's write the rest of them. So guys, your equation for domain and vertical asymptotes are the same. The only difference is we'll have an equal sign for vertical asymptotes. And let me prove to you that we can also go the other way. So look, for n, I'm going to plug in a -1 this time. -1 is an integer. So this is pi over 2 minus a pi. And if you want to combine these, just get the same denominator. So this is negative pi over 2, which is right here. And that's another asymptote. Same distance away. So that equation gives you every asymptote you can think of by plugging in numbers, integers. Okay, so now let's talk about the range. This is facing down, so that's negative infinity to -1 and 1 to infinity. There are no vertical stretches or horizontal shifts. We're just working on the parent function right now. Okay, and your maximums, or you just have one, it's right here at pi -1, and you have two relative minimums here and here. So that's 0, 1, and 2 pi 1. Important note, and it's the same exact note that I made on cosecant. Whenever you're graphing cosecant and secant, your asymptotes, where are your asymptotes always going to be? Yes, your asymptotes are always on the midline. The points that are on the midline. Always on points located on midline. And where does your graph go? Let me graph the cosine function for you. Guys, look, here's the cosine function right here. You see how the asymptote's on the midline? And your graph is always on the maximums and the minimums. Okay? Your graphs are always on the maximum and minimums. Your asymptotes are always on the midlines. Okay. So let's do a transformation. When you see this, you guys are going to graph the sine function. So I'm going to graph this one. Exact same thing, but with the sine. When you start, you need to figure out what the period is. So you can write your number line. So to find the period, remember the formula is 2 pi over the absolute value of b. What's my absolute value of b? Yep, keep it as fractions. So we're going to do 4 pi is our period. All right, so I'm going to write 4 pi, split it into 4 equal parts. This point right here tells me the midline, which is at 1. So everyone, you can sketch your midline at 1. Also, guys, you have a shift right here. It goes to the right. It shifts to the right by pi. So guys, instead of starting here like I normally would, I need to start here because it shifted to the right. So I'm going to go over another pi, and my graph is going to start here because it shifted to the right. And I'll just graph my points. Okay, we're starting here instead of here because it shifted pi to the right. That's why I'm starting there. Okay, now guys, remember, where are your asymptotes? Yep, pi 0, yep. On these points that are on the midline, that's where you draw your asymptotes. So these points that are on the midline is where you draw your asymptotes. And your graph goes on the maximum and minimums. So this was a maximum of sine down right here. And this is the minimum of sine. So that's your graph. Okay, so for the domain, you should have gotten x cannot be, this asymptote is pi. And the distance is from pi to the next asymptote, 3 pi. That's a distance of how many pi's? 2 pi, so I need 2 pi in. That's going to be the same equation for your vertical asymptote. It did not have a vertical stretch or shrink because your amplitude is still 1. Your horizontal shift, we went pi. Okay, let's talk about the range. The range is negative infinity up to this point, which is at 0. And then it continues at 2, and it goes up to infinity. Your relative maximum is right here at 4 pi 0, and your relative minimum is at 2 pi 2. Now we're going to do a transformation on the secant function. Whenever you see secant, you should just go ahead and graph cosine. So I'm going to graph this problem. And you need to figure out what the period is. So the period is always 2 pi over the absolute value of b. This is b, this is c. So your b is 1/2, so this becomes 4 pi. So your period is 4 pi. So I'm going to put 4 pi and break it up equally into 4 parts. That's your period. Now, your C value determines the shift. This is a pi right there. So this went to the right pi. So I'm going to add a 5 pi here because we're going to shift it over to the right. This number represents your amplitude, so I'm going to start right here at pi 2, then here, and here. Oh, sorry, my points are wrong. My amplitude is 2, so I go here. There we go. All right, so notice my amplitude is 2, so from here to here is 2, and from the midpoint, midline to the minimum is 2. All right, and guys, where do you always draw your asymptote? Yep, the points that are on the midline, that is where your asymptote goes. Through the points that are on the midline. Uh-oh. Okay. And when you graph it, it'll look like this. You always graph it on the minimums and maximums of your cosine or sine. There you go. All right, so let's answer the question for domain. Your domain, well, guys, if I continue this function, let's just continue the pattern. So let's say that this was at 6 pi, and say this was at 0, and this is negative 2 pi. Here are your asymptotes, right? These are your asymptotes. So I actually have an asymptote at 0. So my first asymptote is at 0. My next one is at 2 pi. So it's basically 2 pi in. And that is the same function for your vertical asymptote. Oh, you cannot be 2 pi in for your domain because those are asymptotes. Your vertical asymptote is x equals 2 pi in. Your range, it's pointing down to negative infinity, and it goes up to this relative maximum, which is at negative 2. And then it picks up again at this relative minimum, 2, and it goes to infinity. Your horizontal shift, it went to the right pi. Your relative maximum is right here at 3 pi negative 2. And your relative minimum, you have 2 of them. One right here at pi 2, and the other one is here at 5 pi 2. And that's it.